What's my hair?
I have a very strong opinion on hats.
Good, good. Hannah would like to make an announcement, YouTube. Hannah has a very strong opinion on hats.
Like, no.
Yes, she does.
No, like baseball hats. Like, why do we wear them if it's not sunny out?
Why do you wear baseball hats indoors?
I hate it. Like, people look better without hats on.
Thank you, I appreciate that.
Not all the time. I think they look better.
You are allowed to have your opinion, and we're allowed to say that some opinions are stupid. That is freedom of speech, is it not?
Some boys really.
Is it not freedom of speech? I could say that Hannah's opinion is stupid.
I think so.
I could say that,
A
right?
lot of places
Okay,
have
but what's
hats
your opinion
in
on
them.
hats?
Huh?
What's your opinion on hats? Like,
I-
you walking around wearing a baseball cap when it's not sunny out?
My opinion on
No, that's
Well,
what
he
it
does.
my opinion on hats is obviously if I'm outside I gotta be wearing a hat.
Agreed.
But my opinion regarding hats is hats should not be worn inside a building. That's my opinion. But I don't.
If it's sunny out, sure, but
Yeah, but I don't-
If it's cold, sure, but I have.
I don't
Just
get
for
that.
funsies,
So.
we're wearing baseball caps? No, you look better without one.
Speaking of hats, we're going to talk about snow now. The rate of snow accumulation from time 0 to 8 is given by the differentiable function r of t, where r of t is measured in inches per hour and t is measured in hours. Selected values of r of t are shown in the table above. At time t equals 0, there's currently 2 inches of snow on the ground. For the sake of this problem, let's change the 1/4 to 1. Is there a time from 0 to 8 when the snow is accumulating at a rate of 2 inches per hour? Justify your answer. Talk to the person next to you. Why? Go.
I'm gonna say probably. You're right. Either it is or it isn't.
There's only 2 answers, right or wrong.
Yeah, so it has to.
I remember doing this, but I don't know how to.
And it starts at 1, so it has to.
Yes. No.
Yes. Why?
Because
Goes from 1 inch per hour to 3 inches per hour. At some point between those two times, there had to have been a point where it was 2 inches per hour.
Excellent. I'm sorry. R of 0 is equal to 1, and R of 1 is equal to 3. So, without a doubt, Matthew's correct in his reasoning, but the AP exam will not give him the full point unless he says something else. Intermediate value theorem.
Now, for this, would we do IVT or spell it out?
IBT.
I thought it was
Intermediate.
intermediate value.
So that's your way of communicating that you understand that if you start at 1 and you're going to 3, they got to cross over in every value in between. IVT.
Oh, that's like the straight line thing.
Yep.
So you only wrote like the first half, would you just get no points or 1 point, or do you not know?
Depends on the scoring situation. We'll look at some of that coming up. Okay. Is there a time from 0 to 8 when r prime of t, we're not talking about rt, we're talking about r prime of t is equal to 1/2? Justify your answer. Go ahead. Kind of give you a little bit of an idea. See if you can figure this one out.
This is our prime.
Okay, is there? How do you know? This is a rate, is it not?
Yeah.
So let us consider, is there a time when the rate is 1/2? For example, if I look at r of 3, what is r of 3? 4. Minus r of 1 over 3 minus 1. I get r of 3 is 4 minus 3 over 3 minus 1, or 1 over 2. Not the intermediate value theorem, but the
Something.
mean value theorem.
Yeah.
The intermediate value theorem deals with crossing all the values, whereas the mean value theorem talks about the average rate of change.
Wait, why is
Yes.
3 minus 1, isn't
Because I'm going from this time to this time. So it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1.
it? Sure.
Okay? So not only can we say, is there a time between 0 and 8, we could actually say there's a time between 3 and 4. Time between 3 and 4. Okay? So yes, the mean value theorem guarantees r prime of t equal to 1/2. Those are the two pieces we want.
So what is the mean value theorem?
The mean value theorem says this. Suppose that we have a function that has this shape to it, okay? And we're looking from endpoint to endpoint, okay? That represents the average rate of change. Then there must be a spot in between those values. So for us, we said at time 1 and at time 3, there must be a spot where if you look at the derivative is equal to the average rate of change. And that's what we just found, okay? All right, so now it says estimate r prime of t over the interval 0 less than or equal to t less than or equal to 8. So we're going to say that the average rate of change, estimating that over the entire interval, we are simply just going to do r of 8 minus r of 0 divided by 8 minus 0. And we get 1 minus 1 over 8, or 0. And in this situation, what would the label be?
Inches per hour squared.
Inches per hour squared. So notice it starts at 1 inch per hour and it ends at 1 inch per hour. So therefore, the estimate is that it's really not changing at all. Now, did it? Yeah, sure, it went up and it went down. Okay, it increased and decreased. Okay. Use a trapezoidal sum with 4 subintervals to approximate the snow accumulation from t equals 0 to t equals 8. Right now, I would just like you to take 30 seconds and make a guess, talking with the person next to you, how much snow has accumulated during the course of these 8 hours. Go ahead, talk. Just make a guess, okay? 30 seconds. Don't do any calculation. 15 seconds.
More than 2 inches.
5, 6, no.
Wait, what?
Because that's in between.
5, 4, 3, 2, 1, and done. There you are. Okay, what's the guess? How many inches of snow?
4.
4?
That's what I was thinking.
Gotta say something. 6. 5. 16. 12. 10. Okay, so we're going to calculate, we're going to estimate by using trapezoidal sums. So what I encourage you to do when you get to the AP exam, when we did trapezoidal sum together, what we did, and so everything you saw the past couple days was pretty much review. This piece is not review. The way in which we're going to approach this is going to be different for you. You want to lean in because this is something you will be asked to do, okay? So we always used to do trapezoidal sum by doing right hand plus left hand divided by 2, right? That's how we used to do it. That always worked that way because the width of the intervals was the same. When you get to this situation, make a trapezoid, okay? So I'm going to go ahead and make a trapezoid there. I'm going to make a trapezoid there, a trapezoid here, a trapezoid. Oh, goodness. YouTube Nation, she just said she doesn't even know what trapezoid is, and she's going to take the AP Calculus exam.
I also don't believe in hats.
She doesn't believe in hats either, okay?
Hannah for president.
I agree. I would vote for you.
Banning all hats indoors.
So you're not gonna make hats supporting your presidency?
Yeah.
Honestly, you'd be losing out on a lot of money.
You're right. You
You
can
know how
have
many
those,
people
but you
bought
can
those
still
Trump
ban them
in the
indoors.
20s?
Okay, so I'm going to flip the first one on its side because we have a student in here who doesn't know what a trapezoid is. A trapezoid is a 4-sided figure where one set of the opposite sides are in fact parallel to each other, okay? And as they are parallel to each other, it works out that the formula for the area of a trapezoid, and you'll have to remember this on the AP exam, this is a typical problem, comes up all the time. 1/2 times the height times the sum of the bases. And really what that does is, if you think about it, it takes the height times the average of the bases. That's the nature of what the formula is doing. So I'm going to show you this first one. And after you see the first one, you should be fully clear. First of all, what is the width of this? 1. Notice when we translate it over here, 1 is not the width, 1 is the height. Do you see what I'm saying? Okay. Then there are different lengths. Right here it looks like a height to the trapezoid. We have a height of 1 and a height of 3. Or in other words, we have a base of 1 and we have a base of 3. You see that? And so now you can fill it out the rest of the way. What's the base here? 2, 3, 2. And then you have heights of 1 and... Oh, I'm sorry, the first... Yeah. You have heights of 3 and 4.
2, 3.
You have heights of 4 and 3. You have heights of 3 and 1. We've got all these different trapezoids rolling around, right? Hi.
Hi, I got the bases. How'd you get the other numbers?
Well, there are these numbers right here.
Yeah.
So 1 and 3, 3 and 4,
Hold on.
4 and 3. So I pair these two for the first one, these two for the second one, these two for the third, and those two for the fourth.
Okay.
Does that help a little bit?
Mm-hmm.
Okay, so let's compute. You take the sum of the bases, which is 4 times 1/2, which is times 1, which is, so the first area is 2. And yes, what I'm doing is exactly how they are asking you to write this out on the AP exam.
They want you to draw these and write them.
Drawing them is fine. What they actually show within their work, so if we were to actually show the work that they sometimes have, they would do 1/2 times 1 times, is it 1 plus 3? Okay, so that's what they would do. So if you actually look at the calculation that they show on the answer key, they're looking at that, and then we do the next one. 1/2 times, I can't see it anymore, what's the 2? And then what are 2 numbers I'm adding? 3 plus 4. And I do 1/2 times 2 times 4 plus 3.
Oh yeah, it was 3.
So the width of this number is 3? Okay, plus 1/2 times 2 times 3 plus 1. So as we go through this calculation, we can see that the first one, we found that to be 2. The next one is 7.
Wait, it's 7. No, you have to.
1/2 of 2 is 1, and then 1 times 7 is 7. I'll do the last one here. The last one is 4, isn't it? And then the one right here, I have 3 plus 4 is 7. 7 times 3 is 21 divided by 2, so I have 21 over 2. So I have 2 plus 7 is 9. 9 plus 4 is 13. So I have 13 plus, and 21 divided in half is going to be 10.5. So I've got 23.5. So I think whoever said, 16 inches was probably the closest. So, a lot more snow accumulated than what everybody else was thinking.
Alex said 19.
Okay,
Sure.
way to go, Alex.
Thank you.
But you didn't speak up, so it doesn't count.
You didn't ask me.
I pointed in that direction, and he should just give way to Aiden.
You pointed over me.
Okay, all right, we're gonna settle it right now. We're gonna have the 2 arm wrestle. Okay?
Yes, yes.
Are you ready? That'll be a great way to finish this.
I do not think it.
Zizi likes the idea.
I do not like that.
Okay, all right, we'll let it go.
Whoever loses has to wear a hat.
That's diabolical.
Okay.
I've never seen either of them in a hat.
I know.
That's because hats are stupid. And
I feel like
Agreed,
we
thank
do
you.
there.
What is with the
We do
slander
wear
against hats in here?
Yeah, I don't know.
I think
Let's start with Hannah.
people.
I wear hats
Yeah,
all the
yeah.
time,
Hannah,
Okay, but you're blocking
You're
you're blocking the sun out of your eyes.
That is true.
See, that's acceptable.
Hannah's really
The ball marker.
feeling negative about it right now.
Yeah.
So that's all right. Use a left-hand sum. Left-hand sum with 3 subintervals to approximate the amount of snow on the ground at time 6. So this changes as I'm only looking to time 6. Okay. So, and I just want 3, and I want the left hand. So I'm going to go here, here, and here. So again, we're just doing rectangles at this point. What is the width of the first rectangle? The width is 1. What's the height of the first rectangle?
0. No.
Yeah,
0.
it's 0. So everybody agree?
Wait, why is the height 0?
Because we're doing left-hand side.
Oh, no, the height is 1. So we're looking at this number, Aaron.
Oh, that's what I was. Yeah, I was like.
That's all right.
That's why I said no, and then you said yes, and then I was like, wait.
Hold on, what did you just do?
So I have a width of 1.
Yeah.
The left hand is the height. What is my next width? 2. What's the height? 3. What's the width here? 3.
Yeah.
What's the height? 4. So you can see that the first area is 1. The second area is 6. And the third area is 12. If I add those together, what do I get? 19. But it says how much snow is on the ground. How much snow did it start with? 2 inches. What I want you to see here is if it's wondering the amount of snow on the ground, what that is it's the start plus the displacement. So really what you did, and this is what they would love to see, and if you don't do it, it's okay. You could do it just like we did, but the start is 2. The displacement is the integral from 0 to 6 of r t dt. Now, we did 2 plus, and then this thing we estimated by doing our 3 subintervals of 19. So there's approximately 21 inches on the ground right now. Are we okay with that? Okay, suppose that I told you that the snow is gathering at an average rate of 5 inches per hour. Would you say that that's accurate or inaccurate? Inaccurate. Suppose I would say the snow is gathering at an average rate of a 1/2 inch per hour. Is that accurate or inaccurate? Inaccurate. Go ahead and make a guess for what you think is the average rate. Talk to the person next to you. Go.
2.5.
Okay, Alexander Schmidt, also known as the steel trap. What is your
Yes.
estimation?
I am going with 3.
He's going with 3. Let's approximate it. And the average, as you know, is 1 over b minus a from a to b of RT dt. That's how we average the value of a function, is it not?
Yes.
So what number goes out front?
1/8.
1 over 8 times the integral from 0 to 8 of RT dt. And we are going to estimate the integral of RT dt by using right-hand subintervals. So I have 1/8 times, and now let's multiply these out. You guys can look at the top. Tell me what's the width of our first rectangle? 1. And what's the height of our first rectangle? 3. What's the width of our second rectangle?
2.
2. What's the height of our second rectangle? 4. So first rectangle, second rectangle, third rectangle, fourth rectangle. Okay, can somebody tell me what is the width of our third rectangle? What's the height? 3. And what's the width of our last rectangle? And what's the height? 1. So this is the exact type of work that they would love to be able to see. They'll try to follow your work around though and see that you're trying to compute these. So I've got 1/8 times 3 plus 8 plus 9 plus dos, which is Spanish for 2. and I get out of that 22, which will be divided by 8, which is 11 over 4, or in other words, 2.75 inches per hour. Our good friend Alexander Schmidt guessed 3. He is remarkably accurate because he, again, is a steel trap monitor.
All skill.
Who's afraid to arm wrestle?
I am. I would be embarrassing when I lost.
Yep.
I'm weak.
Accumulation, an extremely popular type of problem to do on the AP exam. The next one, arriving and departing. This one, very common, very challenging for people. This one, a calculator may be required. Please take out the calculator. We're not going to get all of this done within this time, but we'll get a good run at it. It says people arrive at a gym. By the way, I really don't like the equation that I picked out. It reads 3e to the t times the sine of t. And we have r of t. I apologize for just kind of the crude numbers we're going to get. I thought there would be more change in people arriving and departing, but I just didn't come up with a very good function. Okay? It says people arrive at a gym at a rate modeled by this. And then people leave the gym at a constant rate. There's 3.2 people every hour that leave. So people are coming and people are going. See what's happening? All right? So there's times where maybe the number of people in the gym will be increasing because maybe the rate is greater than the rate that they're leaving. Or maybe there's times where the number of people at the gym is decreasing because the rate at which they're arriving is less than the rate at which they're leaving. See what I'm saying? These are the things that they want to be able to figure out. It says that there's 50 people at time 0. How many people arrive at the gym during the first 4 hours? How would I figure it out? And I'm only concerned about that function, right? That's it. So just integral 0 to 4 of r of t dt. I will go to my calculator and I type in, what do we have, 3 e to the x sine of x? Crazy function. I'm going to zoom standard. Whoa, look at that guy. And we're going to integrate number 7, and we're going to integrate from 0 to 4. So that tells me that about 31.551 people have arrived during the first 4 hours. $31.551 people. Is that the total number of people in the gym at that time? No. What are we not accounting for when we're thinking about the number of people in the gym? The start and there's people that are leaving too, right? If people are leaving at a rate of 3.2 people per hour and it's 4 hours so far, we can expect that there's about 12 or 13 people who have also left, right? Okay, so just trying to say we're answering that one part. How many people leave over the first 4 hours? Well, that's just the integral from 0 to 4 of our leaving function, which is 3.2. And that's an easy function to deal with, right? You don't need to do all that, but I'm just showing you how I just want to make clear, because they will write it like that on the AP exam. But if you notice, what's the antiderivative of 3.2? 3.2t. And so you're going to evaluate it 4 and 0. So in the end, all you do is you just take 3.2 and multiply by 4. Exactly. And so we get 12.8. So 12.8 people leave. To the nearest person, how many people are in the gym at time equals 2? Well, that really requires a little bit more of an intricate setup. First of all, how many people are there in the gym? That's like a position question, is it not? That's a position question where we consider the start plus the displacement. And so we start with how many people? 50. And we add to that the displacement, which is the people arriving minus the people leaving. So I have the integral from 0 to 2 of the people arriving, which is r of t. And I need to subtract the function of who's leaving. So that's minus 3.2. I will pause there because this is paramount. We have not gone over that type of problem in class. This is new. But does everybody see how that was pieced together? My initial, my arriving, my departing. I would say 1 out of every 2 years that there's an AP exam, we see a problem almost identical to this pop up in the free response. This is one we want to be ready for, and I know it's a little bit new for you. So we go ahead and calculate it. I take out my calculator, I go second calculate, I integrate from 0 to 2, and it gives me 17.421. Hey, come on. Where'd you go? It's gone. I got rid of it, didn't I? It's gone. Did you guys write it down? I got reload. Come on. Resume. There we go. Isn't that nice? Okay, so we have, as I stated, we have the 50. We're going to add the 17 point what? 421. And then we're going to subtract 3.2 times 2, which is 6.4. So I won't write out that integral. We said that it's not necessary. And what did we get? 0.021 people. Yeah, to the nearest person. Sorry about that. 61 people. All right. Love this next question. During the first 4 hours, when is the attendance at the gym increasing? We've already talked a little bit about that. See if you could come up, not up with like an expression, but an idea for how you would say, when is the attendance in the gym increasing? Talk to the person next to you. Go.
When the speed and velocity are different signs. Or the same sign. When R of T
At first I
is
was
greater than
Oh,
3.2. Yeah. How about that? You're such a copier. Those are my exact words.
We need to compare R of T and 3.2, right? Those are the rates at which they're arriving and the rates at which they are leaving. So in other words, when is R of T greater than 3.2? That's when they would be increasing. A very nice way of writing this would be, when is R of T minus 3.2 greater than 0? We love that type of equation because it's that equation that we can readily use within our calculator, because we like to set things equal to 0. Everybody agree? So let's check out that calculator. I go back here and I go to y equals and I type in this function and then I subtract 3.2. And I'm going to look, and does it cross over the x-axis? It absolutely does. It looks like from 0 to about 3 that its bit is greater than 0. So therefore, the attendance is increasing. But from about 3 to 6, it's decreasing. How am I going to find those two spots?
0. The answer is.
I think you're good.
So I did do it.
Yeah, you got the same thing I do.
Oh.
Okay, so I'm going to calculate 0, number 2. I'm going to go over and I'm going to find the zeros. Okay, and I press enter, and I press enter, and enter, and I get 3.120. And I calculate another 0. I go over to this side. and I get 6.293.
Why do we need that?
Oh, first 4 hours, excuse me. I thought it was over the first 8. I'm thinking about the last problem. So that would be from 0 less than or equal to t less than or equal to 3.120. I don't even need the equal signs actually. Just listen.
Where? I'm confused. You lost me after the equation.
So I'm looking at the graph. I'm wondering where is it above the x-axis? So I just found that that spot is 3.12. So from 0 to 3.12, that's where it's above the x-axis. Okay. All right.
How are we supposed to write that out?
You could just say like that, or you could say from time equals 0 to time equals 3.120. And any way you want to write it like that is fine, but they want you to set up comparing it and show that piece. They would really like you to show that mathematics, okay? Is the rate at which people are arriving at the gym increasing or decreasing at time is equal to 3? This will be our last question for the day. Arriving, we are only talking about arriving. So if we're only talking about arriving, are we talking about the 3.2 or are we talking about RT? We're talking about RT. We're wondering, is the rate increasing or decreasing? Okay, rate is another word for derivative, right? So we're wondering, is the derivative positive or is the derivative negative? And that's part of the challenge of the AP exam, is just interpreting that language that you would understand. So it says, is the rate at which people are arriving at the gym increasing or decreasing? We need to consider R prime of 3. And if I go ahead and I go to my calculator and I go ahead and get rid of that minus 3.2, actually doesn't matter if you get rid of it, it ends up being the same thing. But if we look at our original function and we calculate the derivative, and we're going to calculate the derivative at time 3, we could see that the derivative is negative 12. So it's decreasing.
Wait, how did you?
So I can calculate number 6. Yep. Good job. You only have 2 more practice problems to look at, and then it's going to be me not explaining so much. It's going to be you doing stuff kind of on a daily basis. So I'm going to get a couple things in your hands to start practicing. I thought about it. Well, we'll venture into that tomorrow. Okay. Hey, I hope you have a great day. We'll see you back tomorrow. If you see somebody wearing a hat in the hallway, tell them Hannah doesn't like it.
Specifically